In this problem, we're given two functions, f and g, and the first thing we are to find is f of 2 plus g of 2. So to find f of 2 plus g of 2, we first have to find what f of 2 is and what g of 2 is, and then we will simply take the results and add them. So let me go down here and grab a copy of the function f, where I proceed to, rather than have the variable x here, I have some blank set of parentheses to represent the input variable x. So for example, if I want to find f of 2, I need only now put a 2 in the parentheses, and that'll help me find f of 2. So f of 2 would be 2 squared minus 2 times 2 subtract 15. If you want, you can simplify that now. So f of 2 would be 2 squared is 4. Negative 2 times 2 is negative 4, and then you have a subtract 15. So 4 subtract 4 is 0, so I'm left with f of 2 is negative 15. So I'm going to let that sit for a few seconds here, and I'm going to move on to g of 2. So let me grab a copy of the function g, except I put the variable x in here as just a set of parentheses, and I will do the same kind of thing. I would just put a 2 in the parentheses. So g of 2 would be 2 subtract 5. Well, that's pretty simple to simplify. 2 subtract 5 is negative 3. So what we have here is the original problem was to find f of 2 and add it to g of 2. We found that f of 2 is negative 15. We found that g of 2 is negative 3, and we are to add those numbers, which is the same thing as negative 15 subtract 3, which is negative 18. So if you wanted the question and the answer written, the original question was f of 2 plus g of 2, and we just found that that came out to be negative 18. To do f of x subtract g of x, notice that they did not give me a value for x. So f of x minus g of x would be to simply substitute the function f of x with what it was defined to be, x squared minus 2x minus 15, so that's here. And then we are to subtract off the function g of x, and one would be tempted to simply just grab a copy of what g of x was defined to be, x minus 5, and put it there. The problem is by doing so, what you've chosen to do is subtract the first term on g of x, but not the second. So it turns out when you subtract a function, you have to make sure that you subtract both of the terms. This can be indicated by simply putting a set of parentheses. To simplify, I would have x squared minus 2x minus 15. Distributing the negative here, you'd have a negative x. And then distributing the negative here, if you want, you can think of distributing a negative 1. Some students like that. You get positive 5, and you can proceed to combine like terms. So we have negative 2x. Subtract 1x is subtract 3x, and a negative 15 here and a plus 5 are like terms, and if you combine them you'd get minus 10. So here's the question, f of x minus g of x, and our answer is that it's equal to a new equation, x squared minus 3x minus 10. So that is part B. Part C, I am to multiply the function f of x by the function g of x. So let me grab a copy of f of x. F of x was defined to be this, and g of x was defined to be this. And what I am to do is I am to multiply them. So one way to indicate multiplication is to simply put parentheses around the two functions. Now you may be used to the binomial being in front, that works too, but it doesn't really matter. Either way you'll get the same answer whether you distribute the x by these three things and then distribute the negative 5 to these three things, or the way I'm going to do it, because it works out the same, is I'm going to distribute the first term here to both of those, and then proceed to do that with the negative 2x to both of those, and finally the negative 15 to both of those. So let me show you what that would look like. I'm going to start by writing what I would get if I distributed the x squared. So x squared times x is x cubed. Then I would distribute the x squared to the negative 5. That would be negative 5x squared, or subtract 5x squared. And then distributing the negative 2x, you would get negative 2x times x is subtract 2x squared. And then negative 2x times negative 5, a negative times a negative is a positive. And then 2x times 5 is 10x. And then the last multiplication would be if you distributed the negative 15 by this and then to this. And if you did that, you would get negative 15 times x is negative 15x, so that would be written as subtract 15x. And then finally, negative 15 times negative 5, a negative times a negative is a positive, and then 15 times 5 is 75. So now once you've done that, you can simplify, and you can do that by combining like terms. So I have an x cubed with no other like term besides just this one x cubed. And then notice that I have a minus 5x squared and a minus 2x squared. That would be negative 7x squared. And then you have a 10x and a subtract 15x. That would combine to give you negative 5x, and then don't forget that there's a plus 75 here. So if you like the question and answer all written in the same statement, I took f of x, I took g of x, and I multiplied them, and the result was this expression here. Now for part D, I am to find g of f of 2, and off to the side, what I'm going to do is I'm going to start by working on the inside of the parentheses and find out exactly what f of 2 is in the first place. So if you remember, f of 2 was given to be this equation, and I can get a copy of it here again where I replaced the input variable x with several sets of empty parentheses. So finding f of 2 would be nothing more than putting a 2 here, and we did this earlier in the video, and what we got was 2 squared was 4. Negative 2 times 2 is negative 4, and we had to subtract 15, and then I believe I argued that 4 subtract 4 was 0, and we were left with negative 15. My point is, the fact that f of 2 is negative 15 means that whenever I see these symbols here, which I do right here, I can replace it with negative 15. So the way I look at it is all of that work was to find out what f of 2 is, and I found out that f of 2 is equal to negative 15, so I can make that substitution. And what that would leave me with is the g, and the fact that this is now the input into g. So whatever the output of f is, whatever the first function is, whatever it outputs becomes the input into the new function, in this case g. So now what I need to do is take a copy of g over here somewhere, and argue that to find g of negative 15, I need to put a minus 15 in the parentheses. And if I do that, then I need to put a minus 15 here. So that gives me that g of negative 15 is negative 15 subtract 5, which is negative 20. So don't lose sight of what we did. In fact, I can make the same argument that g of negative 15 can be substituted with the number negative 20. I see g of negative 15 sitting here, so I can substitute it with the number negative 20. So if you want, the original question was to find g of f of 2, and what we did is we just found that g of f of 2 is the same thing as negative 20. So this is the question, and this would be the final result that we got. So part E is going to be argued in a very similar way. It looks a little bit more confusing because you're using the same function twice. It's g of 2, but I can explain it in a very similar way to the one I just did in part D. So for starters, you can start by working on the inside of the parentheses here first, find g of 2, and I'll do so by grabbing a copy of the function g. There is g of x, and once more I replaced the input variable x with a set of parentheses. So if I wanted to find g of 2, I'm just working on this inner part right here. That says to plug 2 into the input of g. Doing so, I would find that g of 2 is 2 subtract 5, which is negative 3. And then I can make the argument once again that since g of 2 is negative 3, that when I see these symbols, I can replace it with negative 3. And I do have those symbols here. I have g of 2 here, and I'm going to take g of 2 and replace it with negative 3. And what that will leave me is the left parenthesis here, the right parenthesis, and the letter g, indicating that the output of g now becomes the input into g once more. So we're applying g, taking its output, and applying g again. So let me grab another copy of the function g, And this time I will replace the input variable with -3, so I'm doing this piece right here. So replacing the input variable x with -3, I get that g of -3 would be -3 subtract 5 or -8. G of -3, that's this guy right here, can be substituted with its equivalent value of -8. So if you want to summarize the problem, the question was to find g of 2. And after doing all of that, we found that that comes out to be a value of -8. So it's f of g of 2. And I take the function g of x, and where there's an x, I replace it with 2. So I'm trying to find the value of g of 2. And g of 2 comes out, 2 minus 5 is -3. So I'm going to replace g of 2 with -3, leaving the outer parentheses and the letter f, indicating that the output of g becomes the input into f. So if you come down here, I'm not sure we've done this one before, to find f of -3, I would simply plug in -3 in for the input variables here. So f of -3 would be parentheses -3 squared, subtract 2 times -3, subtract 15, and I should simplify that. And simplifying, I get that -3 squared means -3 times -3, which is 9. This gives a positive 6 when you multiply. You have a subtract 15. This actually comes out quite easy because 9 plus 6 is 15, and 15 subtract 15 is 0. So I get that f of -3 simply comes out to be the number 0. The question was to find f of g of 2. We did it, and we found that its value is 0. So here we're going to do a very similar thing over in these three parts as we did here, except they're not giving me a number. In fact, instead of doing f of g of 2, we're simply doing f of g of x. So this is going to have a different look to it. Rather than working with numbers, we're going to be working with algebraic expressions. And the explanation is going to look a little different, but some of it will seem familiar. So to do f of g of x, for example, what I'm going to do is substitute g of x with what it is. G of x is nothing more than x minus 5. It's been right here all along. So where I see the symbols g of x right here, I can replace it with the notation x minus 5. And if I did that, that would look like this. And then again, keeping the parentheses here and the letter f, I get that now I'm supposed to find f of x minus 5. So let me kind of show you how this is going to look. Here's the function f of x in general. Again, all I did was where there used to be an x, I put some set of parentheses here. And in mathematics, then we usually take functions and we ask you to evaluate them for different values. In this case, though, we're not evaluating it at a number. We're going to evaluate the function at x minus 5. So we are literally replacing the function g of x inside f, as the notation suggested. So if I want an x minus 5 in here, I'll put an x minus 5 here. And if I do that, that means I need to put an x minus 5 here, which means I need to put an x minus 5 here. So to simplify this, I'm going to write x minus 5 squared as x minus 5 times x minus 5. And for good measure, I'm going to copy down the left-hand side, which was f of x minus 5. And I'm going to FOIL these two binomials by taking x times x, which is x squared. Then I'm going to take x times -5, which is -5x. And then this times this would be -5x. And then finally, you would take -5 multiplied by -5, which would produce 25. And then here we have the distributive property where you multiply -2 times x to get -2x. And then -2 times -5 would be +10. And don't forget that you have a subtract 15 at the end. Now it's just a matter of combining like terms. So now I have only one x squared, nothing else to combine with that. I have a -5x and another -5x that would combine to make -10x, but then I have a -2x over here, so a -10x and a -2x would be -12x. Then the constants 25 and 10 make 35, but then you would subtract 15 to make 20. So to summarize, the question was to find f of g of x, and we did that, and after simplification, we got the result x squared minus 12x plus 20. So that was f of g of x, that was g. So now I'll move on to letter h. This time we are to take f of x, that's this guy, and substitute it in right there. In fact, if you just saw that, we're replacing x with this, you could just from that alone surmise the answer would be x squared and then minus 2x minus 15. And the idea would be that I replaced x with all of that, and then you would just have the minus 5 here, and you would combine like terms to get x squared minus 2x minus 20. So if you don't like that explanation, then continue on. If you do, then you can skip later in the video where I do part I. So the other way to explain it is to simply replace f of x with what it is. It's x squared minus 2x minus 15. So I just made the substitution where I saw f of x. I replaced it with x squared minus 2x minus 15. And I would put all of this in for the input into g. And you can think of the function g again as being this guy. But the idea is this is how the function g works. Whatever you want in parentheses here, you put here and simply subtract 5. So like I did before, I would have to squeeze in there. I'm not even going to attempt to do it. I'm just going to write it down that g of x is equal to x minus 5. So normally you'd have an x there, and it would read g of x equals x minus 5. But instead now, what we are doing is putting this stuff in the parentheses. So you can kind of see how my first explanation may have been a little easier to follow. And if you did this, you'd get the same thing I got a few seconds ago. You would get x squared minus 2x, and then when you combine the negative 15 with the negative 5, you would get negative 20. So I'm not going to explain it a third way. I'm just going to say that that is the final answer for that one. So g of x, one way to explain it is to take g of x and write it down twice, where you think of this notation as meaning that we're taking the function g of x and plugging it into g. So the idea, this is the function g of x, and we want to plug it into the function g. Where do you plug things into the function g? It would be right there into the input variable. So if you could imagine replacing this with that, you would have x minus 5 there instead of x, but then you'd have another minus 5, and that would give you x minus 10. However, explaining it that way loses the opportunity to show you the function notation. So the other way to explain it would be to say that we're taking this right here, g of x, and replacing it with what it is. It's x minus 5. And then we are keeping the right parenthesis, the left parenthesis, the letter g, and then from there you basically get the same explanation from there on out, because that basically says that we want to put x minus 5 in to the input variable here, x. So in general, if you let me just replace the x's with blanks, this is to say that we are to plug in x minus 5 there. So now that it's lined up, maybe it'll be a little more obvious that to get the question, we'd have to put an x minus 5 in the parentheses, and then the general rule for g of x is to take that input, x minus 5, and whatever it is, subtract 5 at the end. Doing so would once again give us a negative 5 and another negative 5, which would give us minus 10. And if you feel the need to summarize, that could be put up here along with the question. The question was to find g of x. After doing it in two different ways, if you will, I get that it's x minus 10.